Okay, I want to just finish up talking about z-score, and I put the definition down. So let's just look at the formula. I think actually the formula makes sense in terms of this definition, because this, if you just look at the top, x minus x bar, this is how far x is from x bar. And then if we take that distance and we divide it up into little groups, and each of those groups is the standard deviation, then that will tell us the number of standard deviations that the data point is above or below from the mean. Okay, so I just cooked up an example here with some just made up numbers about a typical SAT score at a college. So I give us the mean and the standard deviation of these SAT scores, and then I give us a student score. So we're asked to find the z-score, and this is a student score. So this means this is going to be like an x, and then the mean, that's going to be like x bar, and then the standard deviation, obviously, that's going to be s sub x. So let's just plug this into the z-score formula and see what we get. So x, that's 1, 2, 4, 3 minus x bar, 1059, divided by 143. Okay. Okay, so I think this calculation makes it kind of clear what this formula is doing. The 184 is just how many raw points the student did above the mean. And then, so what we need to do is, instead of counting raw points, we're trying to count number of standard deviations. So if I took your number of points and I broke that up into groups of size 143, that would tell me how many standard deviations this student is above the mean. I got 1.29 when I rounded it. So this student is outside level 1 and inside level 2 on the empirical rule. So here's just another kind of question. There's just a little bit of algebra involved in this one, but I think it also just makes sense from a statistics point of view. We want to find a student here that has this very high z-score. So this is an unusual student, right? Because their z-score is outside level 2, and also it's really high. So basically what we're saying is, who's really the top of the class? In this context, what SAT score counts as like a really, really good SAT score? So that's the subtext of this question. Let's plug it into the formula and see if we can figure things out. So I'm using this z-score formula up there, and so I'm going to plug in 2.5 for z. The question asks us to find the score, so that means x is going to remain the variable, and then x bar was 1059, and the standard deviation was 143. 143. Okay, so all we have to do to solve this, so now we're just going to solve this equation and figure out how good this student did. So what you need to do is multiply both sides by 143. Okay, so this gives me 357. So this is 357.5. So this is the, if you want to have a z-score of 2.5, you need to score 357.5 points above average. So this is the number of points. And then when I add 1059 to both sides, it's going to tell me not how many points above the mean you need to score, but actually what your actual score needs to be. So I'm getting 1416.5. So if you want to be an exceptional student, and a student with an unusually high SAT score, where your z-score would be 2.5, then you need to score a 1416.5 on the SAT. Okay, the next topic is relative position, and the thing, this is just kind of a cool thing about z-score. It lets you make comparisons between populations that are completely different. So I have a population of warthogs and a population of meerkats, and I give us some statistics about each of these animals. We know the mean warthog weight, and we know the standard deviation, the typical difference between mean warthogs, the typical difference between the weight of warthogs. And we know the mean meerkat weight. And the thing is that warthogs are much bigger animals than meerkats, and they also have much more variation in weight than meerkats do. So without z-score, we wouldn't really be able to compare them. If you told me a warthog and a meerkat, they're such different animals that I wouldn't be able to say, oh, that's a heavy one or that's a light one. I couldn't compare them. But z-score, it really gives us a tool to do exactly that. I'm going to be able to say, really who is bigger relative to their population, Timon or Pumbaa, right? Okay, now I give us some details about a specific warthog and a specific meerkat. So this warthog, we've got a big boy here. He weighs 259 pounds. That's a big warthog. And we've got a meerkat that weighs 2.53 pounds. So that's a big meerkat. So I'm not asking you to figure out which animal weighs more, right? There's no question there. Obviously, the warthog weighs more than the meerkat. We're asking which animal weighs relatively more. So I'm trying to compare Timon to all the other meerkats, and I'm trying to compare Pumbaa to all the other warthogs. So we're seeing relative to their population who is sort of a bigger animal. And this is what z-score can do. So let's calculate the z-score of this warthog. So the formula I'm using is x minus x bar divided by sx. So this warthog, our warthog, weighs 259 pounds. The typical warthog weighs 183 pounds, and the standard deviation is 38 pounds. So I did this math already, and I came up with a z-score of 2, perfectly 2. Also, let's calculate the z-score of the meerkat. So that's going to be our meerkat weighs 2.53 pounds. The typical meerkat weighs 1.9 pounds, and the standard deviation is 0.3 pounds. So I did the math here, and I ended up with a z-score of 2.1. So this means that the warthog is 2 standard deviations above the typical warthog, and the meerkat is 2.1 standard deviations above the typical meerkat. I mean, this makes sense. You guys see the movie, right? There's like a million grubs. They eat whatever they want. I don't know how this happens. They're like in paradise. Yeah, so let's answer the question. The meerkat, Timon, weighs relatively more. And the reason is because he's more standard deviations. The meerkat weighs more because his z-score is farther from 0. So even if I would have had like another animal and I would have gotten like a z-score of like negative 2.7, then this would have been the most extreme animal out of these groups. So remember, I just want to make a note of this, that these z-scores came out to be positive because Timon and Pumbaa are over the typical weight. And if your z-score comes out negative, then that means the object is under the typical amount. But when we're asking for like a more extreme, if they ever ask that question, it doesn't matter if it's positive or negative. You're just going to pick whichever one is farther from 0. So I feel like I've talked this point to death. Please reach out to me if you have any questions or you get stuck on the homework. And I'll see you guys next week.